Okay, everyone, we're moving to the second phase of our session, and this is the live panel session. So if you joined us half an hour ago and you knew nothing about natural hydrogen, you know a lot more now. So thank you to our speakers, Jeff, Eric, and Gabriel, for fantastic overviews of natural hydrogen systems within geothermal systems. So we've got a load of questions coming through on what interesting aspects of natural hydrogen, but I'm going to start with the point Eric made in his talk, and it really struck me that there are known systems that contain a lot of natural hydrogen, but we're not optimizing our geothermal plants for extraction. So what can we do in terms of optimization, Eric? What's your experience here?
So I think the design of the geothermal power plant was made for the vapor and for the geothermal energy, and not at all for the gas production. So we need to imagine that we have to consider also where are the kitchen for natural hydrogen. Is this kitchen the same as the geothermal reservoir or not? That's the first question, I will say, a geological question. And after that, you have also to imagine the technology to separate your vapor if your system is very hot, or your hot water. And so to imagine gas separators that are not a problem for your geothermal production, but that can be linked, that can be put in parallel to your geothermal production and to produce also the hydrogen gas. And maybe to separate also some additional gas you don't want. And there is some idea with some filters, that membrane filters that can separate hydrogen from the CO2. For example, you can re-inject your CO2 in your geothermal field and produce hydrogen. So some idea around that need to be tested. And for that, we need pilots. We need a place to make some experiment and to make some tests. And I think if some people in the geothermal energy, so the producer want to test things in this area, we have a lot to do on the research mode, I think, for the moment. So research and development, it's not operational for the moment. And we need to learn a lot how to organize things to produce both hydrogen and the geothermal energy.
Yeah, great. Jeff, do you want to chip in? I see you ready to
I just
go.
want to add one thing to what Eric was saying is that I think in a lot of these settings that the geothermal resources might be far removed from the potential end uses for the hydrogen itself, and so we need to look at that because the expense and effort to move hydrogen over long distances really can be impactful on the economics. And so if there are a way to co-locate, if there are other things, if either put electrolyzers on site so you convert the hydrogen on site into electrons and put that out to the grid, or co-locate with other things like fertilizer manufacturing or something like that. So if you can use the hydrogen close to the geothermal resource, that also has a lot of advantages.
Yeah, and I guess you've got good examples of that in the States, not with hydrogen and geothermal systems, but natural hydrogen in and around Kansas. You have multiple fertilizer plants up and yeah.
Absolutely. That's really been one of the drivers for exploration in the Midwest in the US, is that there are end uses that are close by, that we're not having to ship the hydrogen over long distances. Yeah.
Yeah, perfect. And I want to touch, you mentioned something else, Eric, that I find really interesting, and Gabriel has touched on it in his presentation. It's the fact that natural hydrogen can occur in these geothermal systems, but they don't necessarily be in the same places as the geothermal wells have been drilled. So let's explore that in a little bit more. So what can we say, or what can we use from our existing geothermal wells to help us understand the potential presence of natural hydrogen? And then what do we need to do after that? And maybe Gabrielle can start on that and then pull in Eric and Jeff for some comments.
Yes, I think we need to use the production of the hot water in order to make the degassing of this water, to make the analysis for the gases, the isotope that are we can measure on those gases, but also the water chemistry. So to have a global understanding of the rock, water, gas interaction in the geothermal reservoir. So I think some data are not available in this area, and very often hydrogen is not measured at all. And so if the people who have access to the hot water, so the geothermal water, can produce the data that are missing right now, I think we will learn a lot, and maybe we will do nice discoveries, and this will increase our database on all the knowledge we need to produce around this connection in between geothermal waters and natural hydrogen.
Oh, and Gabriel, you were gonna go for it.
Yes, and also with geothermal wells, to look at cuttings will be very interesting for us to see, for example, the iron ratio, iron 2 and iron 3 ratio, to see what can be produced more, the remnant production, or what has already been produced, and to have an estimation if we found a source rock, to estimate the potential of the field.
And in that, it's natural hydrogen, it's not going to come up and slap you in the face. You have to look in detail at the data to understand. And there could be many geothermal systems that host natural hydrogen, and yet people just simply haven't looked or collected the right data to understand those. Is that fair, Geoff?
Yeah. And to build on what Eric and Gabriel have said, I would point out that in the best places for the geothermal resources might not be exactly co-located with the best places for the hydrogen. They are, we are interested in the gas phase commodity, and so we need to look at the pressure temperature conditions, and you could have single phase or two-phase fluid movement. And so if you have a free gas phase moving into different areas, that could actually be the target for hydrogen exploration. But the same tools, the geophysical methods that we're using to image the subsurface and get the tectonic framework and the structural geology and so forth, that is directly applicable in both. And at the end of the day, the geothermal may be drilling, targeting one site, and then the hydrogen might be targeting an adjacent site, something like that.
Yeah, I love it. And that's hopefully where some of our phase one mapping efforts will help the natural hydrogen community, and we hope that there's a good crossover in those products. And talking,
maybe,
sorry,
maybe Helen, a comment is also when the people are drilling the geothermal wells. I think a nice gas monitoring, so the gas while drilling monitoring is needed, and we need to have hydrogen on the list of gas we want to analyze during the monitoring of the mud during the drilling operation, because very often hydrogen is forgotten or is not analyzed, on that we are missing probably nice information about the hydrogen system, just because we are not measuring hydrogen in the mud during the drilling operations.
Yeah, absolutely.
I just want to caution, though, that sometimes you can have drill bit metamorphism that will generate hydrogen, and there's potential for artifacts. And so I would advocate that we want to look at a suite of gases, as Eric mentioned in his talk, looking at other things, helium, other gases. So it's complicated. It's not as simple as just seeing hydrogen as you're drilling, but more effort needs to be directed into this. Absolutely.
Yeah. But thankfully, sorry.
Yeah, maybe Geoff, if you have an important venue of hydrogen, you will see a peak, and that is not your drill bit background.
Yeah, absolutely.
Yeah, I think the fantastic thing is that, having spent many, many years doing gas monitoring for oil and gas, we've made so many more advancements in gas monitoring, both with the in and out flux of gas and measuring what goes in versus what comes out systematically, collecting not just the natural gas, but the isotopic ratios of the gases as well. And I completely agree. You gotta throw everything at it, because we're ever increasingly seeing metamorphism by the bit. Just as drillers want to drill faster, one of the downsides is you drill hard, you actually start to metamorphose those rocks. So yeah, great points in that. And actually on those gases, one for you, Gabriel, because you talked about H2S, is there environmental risk associated with natural hydrogen production in these systems?
It does not involve more problems than a conventional geothermal operation, I think. It is simply a matter of capturing and separating the gas that is lost today. And today, H2S is not recovered, but reinjection into the system to produce privatization reaction, for example, could theoretically produce more hydrogen. In this case, hydrogen is a co-product also of this geothermal energy, so it might as well be valorized. And today, hydrogen is manufactured, transported, used, and so there is no greater risk with this natural hydrogen, and also with this H2S, because today this H2S is lost. So to re-inject it and produce more potential hydrogen, I don't think there is more risk than other geothermal producing field.
Yeah, that makes sense. Good. And we jumped to that one, but maybe before we jump on to, I've got some nasty questions on policies, etc. But before we leave gas, what we've talked about short-term recognizing natural hydrogen within an exploration or an early stage system. What about long-term monitoring? Because it explain to our audience that don't perhaps understand natural hydrogen that it can be ongoing regeneration, and there's examples that you continuous flow of natural hydrogen. How do we monitor this long-term and see different fluxes? And open to whoever shouts first. Go for it.
No, maybe I can try to answer to that. I think what we have now is only short time measurement of only one gas analysis on a water sample, and probably we will learn more if we can monitor on maybe months or year the flux of hydrogen that is produced in some geothermal wells. For example, in Iceland, we have only some instantaneous measurement of gas, but we have no long chronic of production of hydrogen with the water. So we don't know if there is some variation of quantities of fluxes, and we need to record that also.
You know, Eric, I don't know if you've seen some of the publications from the geysers in California, but they did actually measure hydrogen in some of those fluids going back, I want to say back to the 1930s. And they've been periodically over, you know, in the ensuing decades, they have occasionally gone back and re-looked at them. And surprisingly, the hydrogen concentrations have remained surprisingly quite consistent. Although I don't know how representative the geysers are of geothermal systems in general. I think that it's one of the few places where we do have a very long temporal record, although it's just instantaneous measurements, you know, over a period of decades. So still, I would expect that in a lot of other places you see much greater fluctuations in the concentration. But and I agree, we need to do a lot more of that type of work. We don't have very many cases where we've looked at this over any significant amounts of time.
Maybe, Gabriel, you have tried to monitor in Assal or in Djibouti some on a long term some wells. I don't know. I've seen your work, but I don't know if you produce long chronic.
No, we didn't produce that data. We only have data for 1 day, one measurement each 30 minutes for 1 day, but it's the best we have, and we didn't monitor for 1 week or for 1 month. but it will be very interesting to do that, as you said.
I think this is completely missing, maybe with the exception of Geyser in California, but we need to record more data and to have a permanent monitoring of interesting wells.
Yeah, no, that's great. And it's just to remind our audience, there's just so many ways that water, rock, and gas interact to form hydrogen that it will help our understanding by continuously monitoring as well, not just at one side, but in terms of the process. If shift slightly, but maybe along this theme. So we always talk about emerging technologies in geothermal, and whether it's drilling, EGS or technology to help us drill. What about emerging technologies in natural hydrogen extraction, particularly in geothermal systems? Any thoughts? Eric, I believe you have some thoughts. Do you want to start off?
No, I think the work on the gas separator clearly can help a lot. There is a lot of idea in this area to separate hydrogen from the water vapor, of course, but from other gases in order to produce only hydrogen and maybe helium at the same time. So gas separator, clearly we need a breakthrough in this area to have something that a design of the technology that can help for the production of hydrogen.
Well, one thing I would add, and this isn't really a single technology, but that the exploration strategies and techniques that we need for natural hydrogen are not, fully developed yet by any means, and we have a great foundation from the petroleum exploration world, as well as from mineral exploration and geothermal. But what I think is really needed for natural hydrogen is a convergence of these. We need to adopt and adapt these exploration strategies from all of those disciplines and combine them in a new way to then come out with a best practices for actually how we have a workflow for natural hydrogen exploration. And so there probably will be some new algorithms, data processing, and so forth that are needed. But in general, a lot of, I think, is really existing technologies that we have. It's just a matter of using them in novel ways and combining things in ways that we hadn't previously done before.
Yeah. And do you think it's because it's so much complicated? Because you can't just be a geologist and you can't just be a chemist. All of a sudden you have to be a hydrologist, a geologist, and a chemist. Is it because it's like a different fusion of skills that we have to bring together? Is that the barrier?
Well, yes, I would say that's true. But I think that's also the case in the petroleum industry. We have geochemists, geophysicists, we have fluid dynamicists. And so we've done these things. And the mineral side, they also have faced these challenges. But we're now, asking different questions. Where would the hydrogen be generated? What are our hydrogen source rocks? What are the kinetics of hydrogen generation? And so we need to adapt our models and our exploration tools now to answer these questions that we never really thought of before.
Yeah, and maybe one for Gabriel. So to kick that off, I mean, what we're learning at Project InnerSpace, it all starts with the data and databasing and having consistent data and metadata. Is there a hydrogen database out there that when you go to the field and you gather data, is there a global database that's been established like there is for the international heat flow or what we're doing in phase one?
So yes, it depends on what kind of field you are looking for your hydrogen. But for example, for my field in volcanic area and geothermal area, I obviously look at the heat flow, but also all the known fumaroles and all the volcanic data, geophysics. If there is bubbles, springs, bubbling springs, but in fact, if you have data, it's good, but on the field, it's the best thing to do is there is no other way to tell whether hydrogen is present or no, is to analyze the composition of the fumaroles or from the bubbling water or whatever. But there is some proxy, we can say, for this hydrogen in these volcanic systems. Altered or hydrothermalized soils, or the presence of sulfur, sulfides around emanation can guide you with this hydrogen, of course. And to know the geology of the field, if there is iron-rich rocks and what kind of rocks also.
So I'm going to stop you because I can't believe it. We have 1 minute left. So I'm going to ask all three of you 3 things that you would tell the geothermal community to do to improve their knowledge of natural hydrogen. Jeff, you can start. And if it's the same, just go.
I would start by reading that paper, the review article in the journal Science that came out in February. Very nice summary. Reach out to us at the USGS. We have some resources on our website. We will be putting out a map of prospectivity for the United States for hydrogen coming out later this year. And just keep your eye on the news. There's a lot of discovery, a lot of activity, new wells that will be drilled. And so, pay attention to what's happening in this space, because there's going to be a lot of exciting developments, I think, in the very near future.
And we're done. We didn't even get to our Gabriel. But we're going to have to end it there. I want to say massive thank you to all 3 of you. It was a fantastic discussion. Thank you to the Pivot team for hosting us. And if you enjoyed this, if you like your rocks, come back the same time next week and you can hear all about Phase 1 mapping project with Project InnerSpace. Until then, keep safe, enjoy the rest of Pivot, and thank you very much. Good evening.